This is Algebra Lesson 3-2, solving multi-step equations. Many problems require more than 2 steps to solve. When that happens, you just need to do several more steps than just 2 to solve the equation. Most of the time, you'll need to collect like terms on one side of the equation to the other. It doesn't matter which side. Some people like to move them all to the left side. Some people like to move them all to the right side. Some people mix it up and like to try to make variables to be positive as often as possible. It doesn't really matter as long as you get the variables on one side of the equation or the other. Distribute when necessary. When you see the distributive property, you must distribute before you add or subtract anything. Then isolate the variable all by itself, and then solve. Let's take a look at some examples here. Let's take a look at this first example. 2c plus c plus 12 equals 78. If I was to look at this, I can clearly see that I have some like terms here. 2c and c have the same variable. If I were to combine those two together, they would become 3c. So 3c plus 12 equals 78. Now, this is a simple 2-step equation. All I need to do is get c all by itself. They added 12, so I will subtract 12 from both sides of the equation. I now have 3c equals 66. Divide by 3, and c equals 22. Again, I can check my equations by just plugging into the original equation, 22 back in for c, and I would know if I was right or wrong. Let's look at equation number 2. We have 3x minus 4x plus 6 equals negative 2. Again, there's no distributing I need, but there are some like terms. This 3x and 4x can be combined together to make negative 1x. Be really careful, don't lose your negative signs. 3x minus 4x is negative x, or negative 1x if you prefer it, plus 6 equals negative 2. Now to get x by itself, I'm going to subtract 6 from both sides of the equation. If I do that, I get negative x, or negative 1x. These two cancel out. Negative 2 plus negative 6, or negative 2 minus 6 is negative 8. I don't want to know what the opposite of x is. I want to know what x is, so I will divide by negative 1, and I will get x equals 8. As simple as that. Look at equation number 3. Okay, and equation number 3 says 3a plus 6 plus a equals 90. Here we have a 3a and a positive a, which makes 4a plus 6 equals 90. You have to be careful with your variables to make sure you don't lose your negative signs. Don't look at this and say, oh, I have to subtract a here from here, because here's the dividing line of the equation. Both of the a's are on the same side of the equation. Therefore, all you need to do is simplify. You don't need to subtract this a right here, because if you do, you're going to end up messing up your equation really, really badly. They're both on the same side, so we will combine those like terms to get 4a plus 6 equals 90. If I subtract 6 from both sides of the equation, I now have 4a. These two 6's cancel out. 90 minus 6 is 84. Divide by 4, and a equals 21. Let's look at a couple of problems in which we have to distribute before we can do any solving. If we look at these two equations, we'll see that we must distribute so that we know whether or not we need to combine any like terms. So I'm going to look at this first equation, 2 parentheses x minus 3 equals 8. So I need to distribute this 2 throughout this entire parentheses. So I get 2 times x, which is 2x, minus 2 times 3, which is 6, equals 8. Now it's a simple 2-step equation. I simply need to add 8 to both sides. Oops, what am I adding 8 for? I'm not supposed to add 8, I'm supposed to add 6. I almost made a big mistake. Add 6 to both sides. These will cancel. 2x equals 14. Divide by 2. X equals 7. If we look at this second example, we need to be especially careful with our negative signs. If this messes you up, you might want to rewrite this as 15 equals negative 3 parentheses x plus negative 1 plus 9. So that when you distribute this negative 3 throughout the equation, you'll make sure you distribute it to the negative 1 as well. So now when I distribute this, I will get 15 equals negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3 plus 9. Again, Here's the dividing line between my equations, so I have to look and see if there's any like terms. These are like terms. I can add them together. So I get 15 equals negative 3x, 9 plus 3 is 12, so we get plus 12. Now to solve for x, I simply need to subtract 12. I will subtract 12 from this side, subtract 12 from this side. These will cancel. 15 minus 12 is 3 equals negative 3x. Now I divide by negative 3, and x equals negative 1. Let's look at example 3 here. Example 3, again, more negative signs. If you're afraid you're going to mess them up, it might be a good idea to rewrite this as 3 minus 3, parentheses, or plus a negative 3 for some of you, parentheses, x plus a negative 5 equals 69. That way you don't lose any of your negative signs. Now when I take this negative 3, sign goes with number, and distribute it, I'm going to get 3. Negative 3 times x is negative 3x. Negative 3 times negative 5 is positive 15 equals 69. Again, this is the dividing line between my equation. I can look and see if I have any like terms. This 3 and this 15 are like terms. Both of those are positive because this negative sign goes with this 3x right here. So 15 and 3 is 18 minus 3x equals 69. Now I simply need to get x by itself. So I will I will subtract 18 from the left side, and I will do the same thing to the right side. These will cancel. I have a negative 3x. Don't lose that negative sign. And 69 minus 18. 9 minus 8 is 1. 6 minus 1 is 5. Is 51. Divide by negative 3. And x equals, let's see, 3 goes into negative 51. 1 time, 17, negative 17 times. Second part of this, let's see where. Part 2 of the solving multi-step equations talks about how to clear a fraction or a decimal from an equation before you start solving it. Because if you're like most humans, we deal better with whole numbers than we do fractions and decimals. So if you can clear a fraction or clear a decimal, it makes it much easier to solve. For example, there are 2 ways to clear a fraction or a decimal before solving. The first one is to get a common denominator. I get a common denominator. If I look at this, I need to find a common denominator between 4, 8, and 2. So in other words, if I was going to add these fractions together, the common denominator would be 8. So if I take and multiply everything in this equation by 8, okay, take that back.